Ready, Chief?
Aye, aye, Captain!
I can't hear you!
Aye, aye, Captain!
Oh!
Alright guys, this is our final product for the dice part of the board game counter, and we're just going to walk it through 1 through 6 just like on a dice, and here we go. Here's 1, and there's 2, then you flip it to 3, there's 3, then you go to 4, and there's 4, and there's 5, and then there's 6. And we'll be explaining on how it's counting 1 through 6 by flipping these switches, and how the logic of all the gates on these integrated circuits work.
Hey guys, I created this very simple setup to show you some of the basics of what's going on in the circuit we're about ready to show you. And so on both of these, I hooked them both up to the 5 volts and 0 volts. That's your power and ground. And as you can see with this first one here, it's hooked up to the power. You can call that on, yes, or 1. And likewise, this switch right here is hooked up to the ground. That's 0 volt. And you can call that off, no, or 0. Okay, this is one of the gates we used in the circuit. This is an AND gate. As you see, it has 2 inputs, A and B, and 1 output of C. And in a scenario where A and B are both 0, C is also going to be 0. And see, when A is 0 and B is 1, it's also going to spit out a 0. Same thing for the next one. But this thing will only put out a 1 for C when both A and B are 1. Okay, and this is an OR gate. As you can see, just like the AND gate, it also has two inputs, being A and B, one output being C. But what's different about this one is that only one of the inputs has to be a 1 in order for C to be a 1. As you can see, the only outcome where C is 0 is when both inputs are 0. Okay, and this one is an inverter gate. As you can see, it only has one input and one output. And pretty much all it does, is, just like the name implies, is it inverts the signal. When A is a 0, B is going to be a 1. And when A is a 1, B is going to be a 0. Binary is a number system with a base unit of 2. As you can see, 2 to the 0 would be a 1. 2 to the 1 would be a 2. 2 to the 2 would be a 4. 2 to the third power would be 8. These values are represented through binary using 1s and 0s. Say in the example we had, let's go 1 0 0 1. See, this one right here is going to translate out to being 8. Since these are both 0, we don't mess around with those. This is going to stay a 1. Just add those two together, and that is going to stand for 9. Okay, just another example. Let's see, we could have 0 1 0 1. See, 2 to the 0 power is going to be a 1. Since this is 0, we're not going to mess with that. See, 2 to the second power is going to be a 4. Add those two together, you're going to have 5. This is a chart I just made to show you all the various combinations you can do using 3 bits. You can count from 0 to 7. And just like on the previous example, you have 1 0 1, and that's 5.